We're talking percent proportion, which might sound kind of strange. I'm gonna go ahead and read this right here just so that maybe we can try and get a handle on what the heck this is. In a percent proportion, one ratio compares a part of a quantity to the whole quantity. So that right there, let's do some quick highlighting. One ratio compares part to the whole, and the other ratio shows the equivalent percent written as a fraction over 100. So equivalent is a big deal here because now they are equal. They have not been equal thus far. We just did a whole test, a whole thing over ratios and proportions, and at no point did we ever say that the ratios were equal or that the proportions were equal. And my explanation behind that was, let me zoom out and visualize here. If here is the class, and in this class there is 1, 2, 3 guys and 1, 2, 3, 4, 5 girls, then if we compare to the whole school, and in the whole school we say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 guys. So 3G, that's a weird looking G, 3G, and down here we say there's 12G. That's for guys. I guess guys and girls both start with a G, whatever. Then down here, we would expect there to be 20 girls because of the proportion times 5. This one was 3 to 5. This, sorry, not times 5, of times 4, right? Because 1, 2, 3, 4. So times 4, so 12 over 20. These ratios work because it's times 4. And so that's why it's proportional. But those are not equal, right? It's pretty obvious that 3 students does not equal 12 students, right? So let's go back over here. Another way we can write this, and this one is a little funky, is over of. And that is going to be, guess what? Equal to a percent over 100. Now, the wording here is what's going to stick out. This one you use on brief word problems like these. The wording right here you use on larger word problems like these. And if you're going, I am confused, is over of, what the heck is that? Well, let's check it out right away. 12 is. Okay, so hang on. Let me go ahead and write is over of equals percent over 100. Is over of. Well, is going to go right here. In fact, I'm going to erase it and write it so it's all clean. Boom, 12 is what percent? You say what when you don't hear someone correctly. When you're like, wait, what? I don't know what you're saying. Well, I don't know what the percent is, so that's why I'm going to call it X, okay? And then the last bit of information is of 80. It's like there's an of right here, and we can write 80. So, you might be thinking to yourself, listen, Mr. Math, I could have figured out what percent of 80 12 is without doing this little thing. You know what, you might be right. Here's the thing. Starting with some of the ratio stuff, and definitely with percents, if you can figure it out your own way, go for it. And what I mean by that is, take a look at this picture we got of LeBron here. How many of you are going, LeBron, how selfish of you. Look at this player right here. He's wide open. You should be passing him the ball. If you are working a problem and you are this far from the bucket, nobody's going to blame you for just saying, hey, I dunked now, okay? You're not going to have to come up with a game plan. You're not going to have to pass, okay? But if you look at this problem and you go, what? Then you need a game plan, right? So now imagine if LeBron is, here's the court, and there's center court, there's the baskets. LeBron's right here. Look at him, how handsome he is. And he needs to get down here and score 2 points, 3 points, whatever, and there's 5 seconds left. Does he just say, oh yeah, I can run down here and I can score in 5 seconds? Maybe he does, but maybe they also come up with a plan. Maybe they stop and think for a second, right? That's what these are up here. Maybe you need to stop and think. Maybe you need a plan because you can't just dunk it right away. So I will talk about times where you could dunk. I feel bad for this guy. I'm going to erase that. There you go. Whoever you are, good for you for being a Laker. I will try and point out the times where I'm like, hey, listen, you could have done this, but I'm not going to be able to do them all. In fact, today, I've taught this lesson 3 times, and the very last class today, somebody said, why don't you do that? And I was like, dang, that was good. I didn't even think of that. So it happens that you got to just kind of listen and enjoy and find out, okay? Okay, so what would you do at this point? You were going to cross multiply. 12 times 100 is 1,200. X times 80 is 80x. Now pause. What the heck is cross multiplying? Did you know you could cross multiply? You can cross multiply. You can cross multiply. There's a y, I promise. When you have a fraction equals a fraction. So let me show you what that looks like. If you had like 2/3 equals x over 4, cross multiply, you get 8 equals 3x. You could do that. But a fancier, like someone with some understanding could realize all we did was kind of creatively multiply. So what if we just had like 7x equals 1/4? Guess what? We could just multiply like this. 4 times 7 is 28. And then this 1 is still just chilling. He's just right there. So if you're like, oh, dang, we can only ever cross multiply if we have a fraction that equals a fraction. Not necessarily. You could here. It might not make sense to do that, though. Okay? And in fact, let's just move on. That the idea is that when you have 2 fractions equal to each other, you can cross multiply, and you end up getting what we got here. Now, we're trying to get x by itself. So we are going to divide by 80, because 80 is multiplying x, and the opposite of multiplying x is dividing. So here's what happens. The 80s cancel, and we have x alone on this right side now. And here's where we can either get a little creative or a little annoyed. We can divide, and we can go ahead and do that. So this is what it equals, but that's not quite a final answer. You could either just do 120 divided by 8, or you know what? We could sit here and look at this and go, wait, that's a fraction. What if I divided them both by 4? Because I see that 12 is divisible by 4, 8 is divisible by 4. Well, then you would get 30 over 2. And you know what? I bet you could see that that equals 15. So if you're like, wait, is this the LeBron James dunk thing you're talking about? No, it's not. It is the LeBron James dunk. If this is what you had and you wanted to get here, this could be faster than if we just did long division, right? Because long division looks like this. You go 1, 8, you subtract to get 4. Bring down the 0, 8 goes into 45 times. I mean, that wasn't that crazy because these numbers aren't that crazy. But the idea is that either way, we found that the answer is 15. Now, before you start to celebrate, yay, we're done. 15 what? And if you're like, what do you mean 15 what? Well, here's what I mean. 12 is what percent? So this is 15%. It is possible that the answer could have been like, oh, it's 15 miles. Not on this one. right? Because it's 15%. So here's what I'm going to do. I am going to work fewer problems than what I did in class, just because there was a lot of you in class. And if you need some help, this video is here to kind of help get you off the ground. But I'm not going to do quite as many as I did in class with you, because that was like an interactive thing. And if you're like, what the heck is he talking about? In class, I had students do these 3 problems. And then I did probably these 4. So I ended up doing like 5 of these problems. I'm not about to do that many this time. Sorry, I love you, but it's just not going to happen. So here's what I am going to do. I'm going to jump and do, let's see, how about, you know what, let's go for it. What is 70% of 150? You guys, this might be a LeBron-like problem. Do you know why? Because 70% of 150, we could just find 10% and then multiply that by 7. So 10%, you just move the decimal 1 place. That's 15. And if you're like, I don't want to do 15 times 7, dude, you are complaining about the wrong thing. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 105. 105 is 70% of 150. Here's your math. That seemed very easy. Yep. It was this. Okay. If you're like, but I don't get it. I feel like I'm over here and cannot just dunk it. Okay. Well, then let's not just dunk it. Let's do it. So if you're going to do it, then one thing you could do is write is over of equals percent over 100. If you're like, why would I ever do that? Sometimes it just helps to see, hey, this is what I'm trying to do, and then you can fill in from there. So what is the is the thing that we don't know. I'm going to put an X over the top of that because I don't know it. 70% of 150 of 150. And now this should just work like that. So 100 times X is 100X. 70 times 150. Okay. This one might be a little frustrating for you because you're like, man, I have to do 70 times 150. Yeah, you might have to. But here's what you could do. You could do 150 times 7. You could do 15 times 7. If you did this, by the way, your final answer would have to add a 0 to it. If you did this, your final answer, you'd have to add 2 zeros to it. And if you're like, why? Because we took a 0 from there, because we took 2 zeros from there. And if you're like, I'm not trying to do all that complicated stuff, let's just do 150 times 70. Let's go. 0 times 0 is 0. 0 times 5, 0 times 1. Cool. We are done with the 0. So now we're going to move on to the tens place, which is why that 0 is there. 7 times 0 is still 0. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. So the answer is 10,500. And you already know that the answer is 105. So maybe now you can see that, yeah, when we divide by 100, we get 105 pretty smoothly. So what was the trickiest part of this? Maybe it was setting it up. Maybe that's what you're thinking. Maybe it was actually just multiplying it. Maybe it was dividing. I don't know. But you have this approach or you have this approach. Okay? Let's do a couple more. Number 4 I'm going to do because it doesn't say what. It just says find 95% of 140. Okay? So is over of 140, 95%. We're looking for what the is in this situation. You could cross multiply and get 100x, and you could cross multiply here and get 140 times 95. Okay. 5 times 0 is 0. 5 times 4 is 20. 5 times 1 is 5 plus 2 is 7. We're done with that, so we're on to the tens place, 9 times 0, 9 times 4, 9 times 1 plus 3, we get 13,300. So really, this should be fairly easy at this point, because dividing by 100 gives you x, dividing by 100 gives you 133. So again, that wasn't that crazy. However, maybe you saw that, listen, 95%, if I just find 5%, then I can subtract that and get 95. And in fact, wait, what do you mean subtract it? Subtract it from 100%. So how do you find 5%? Well, 10% of 140 is 14. And so to find 5%, you divide by 2. So this will equal 5%, which is 7. And check it out, 140 minus 7. And in fact, wait, what? 100% minus 5% gives you 95%, and that gives us 133. Was that easier? I don't know. You have to figure that out. But I can tell you, like, 6, 7, 8, even 9 are problems that, like, I'm glad that I have is over of to do them, because I don't want to find 23% and then subtract it from this number. I just don't want to. So I'm going to go about the is over of route. So here's what we get. 77%, 77 of what? I don't know. Is 100.1. So we cross multiply, and 100 times 100.1 is 10,010. Sounds kind of weird, but it is. And then x times 77 is 77x. So now we're going to divide both sides by 77. So we get... Now, I have to point out, I did this problem in every class, and I kept screwing it up because of just my level of organization. I was trying to go fast. Why am I telling you this? Because that's what students do. That's what people do. We want to go fast, and we're sometimes disorganized. So slow down. Do this with me. 77 goes into 1, no. 10, no. But 100, yeah. Now, here's where I made my first mistake. I accidentally called this 33 in one class. That's not 33, because it would be 23, right? If you need to see it, you borrow from the 10 to get 9 to make this 10. 10 minus 7 is 3. 9 minus 7 is 2. And if you're like, dude, I don't borrow. I don't know what that is. Sorry, dude. This 1, see how he's kind of small in there, and this 0 is big. I know that seems silly, but you got to bring down the 1. So how many times does 77 go into 231? And you might think you have no clue, but you just have to kind of think through. If I had 70, 2 70s is 140, 3 70s would be 210, and 4 70s would be way too much. So let's try 3. 3 times 7 is 21. 3 times 7 is 21, but plus 2, I get 231. Oh my goodness. We get 0. Now here's how I screwed up again, is I stopped there. But hold up, this 0 needs to drop down. And you actually have to ask, how many times does 77 go into 0? It's 0 times. So the answer is 130. 77% of 130 is 100.1. So that is our answer. Let's go backwards and kind of fill in these sentences. 90% of 140. So 95%, I guess this one isn't much of a sentence because it's not a question, right? So we can skip that one. Oh, you know what? We did it over here too, so we can move on. So here's the thing. From here, I had students try this, and this. We skipped those two just because, listen, we've had a handful of examples, and guess what? Now so have you. So we flipped to the back where we didn't do these two, and we tried to do these 4. And I say tried to, I mean, we did it, but we used this right here. Part over whole equals percent over 100. I'm going to write that over here. Part over whole equals percent over 100. And we use this because these word problems are going to describe part of a situation. So think of it, I use the example in class as like part would be if I have an apple slice. So here's my apple slice depiction. I know apples aren't yellow, but that's like the apple slice. That's the inside of the apple. And then here is my attempt at drawing a 3D apple where there is a slice missing. Okay, you ready? This is my 3D apple where the slice is missing. Okay, so if you don't see it, I'm so sorry. Here's what happened. This slice really is in here. And the idea is that if I had, let's say I had 3 apple slices, well, that would be like 3 parts. But a whole apple, if I had 3, maybe it takes 9 slices to be the whole apple, right? And in fact, I don't get it. Well, think about it. If I cut the apple, here's a bird's eye view of the apple. If I cut it, I should not have chosen 9. Let's go with 8, because that's going to be way easier. If I had chopped it into 8 pieces, and I took out 1, 2, 3, the idea is that you would need the rest of this apple. You need the rest of those slices to make a whole apple, right? And then this whole part with the percent and the over 100, maybe we are trying to figure out what percent of the apple is 3/8 of the apple. We could do that. But don't worry, we're not going to do that because we've been doing that, right? So let's just jump into this. I want to show you that for every problem I give you, pretty much for all of these, you could be writing blank equals blank over 100. And if you wonder why, it's because that's the only part of this equation that doesn't change, okay? It's 100 every time. And also, I've seen some people do this. They've done blank over 100 equals blank. You can do that too, because then all you've done is put the part over whole on the right side and the percent there. You can do that, that's fine. So anyway, Hannah has a goal of running 42 miles this week. By Tuesday, she had completed 20% of her goal. So 20% of a goal sounds like not the whole thing, right? And it also is the percent. And if you're wondering why I almost started to write it right here, is because this side is talking about the part of her goal, right? The whole goal is 42, and we don't know how many she actually ran. Now, some of you might say, hey, listen, I could find 20% of 42 real easy. And that makes you LeBron. Remember? That makes you LeBron with the ball right by the hoop. Cool, go for it. But if you need a game plan, boom, we got a game plan, right? So now in our game plan, we cross multiply and we get 100x. We cross multiply and we get 840. If you're thinking I'm a super math genius, here's what I did. 42 times 2 is 84. And then I need to add that 0 in, because here's what I've done. I basically multiplied by 2, then multiplied by 10, and that's the same as multiplying by 20. Divide both sides by 100. Why are we dividing? Because right here, x is multiplying 100. And how you get rid of multiplying by 100 is dividing by 100. So now we're left with the x. And whenever you divide by 100, you take the invisible decimal and you move it twice to get 8.4 miles. And again, if you're like, yeah, I could have done that. Cool. Glad you could have done it. Maybe not everyone could have done it. That's why we did this. Let's try 14. There are 84 jars of jelly on a shelf at the store. Of these, 21 are grape. I just heard a part of the shelf is grape. The whole shelf is 84 random jars of jelly. And then we want to know what percent are jelly, or grape. So we're going to cross multiply. Let me change colors. We get 84x. We get 2,100. And now we are going to, just like we did before, we're going to divide by 84. So I'm going to do just long division, okay? You might think, I don't want to do that. You can do it however you like. If you want to divide both of these by 2 and do that over and over and over, go for it. I'm just going to do this right here and get 2 times 4 is 8. 2 times 8 is 16. When I subtract that, I get 42. Yep. And I bring down this 0, and it's 5. 5 times 4 is 20. 5 times 8 is 40 plus the 2. So 25 what? 25%. Because it asks for what percent. Our X was in the percent place. So 25% of this was grape jelly jars. So here's the thing. In class, I might have done a couple other problems, but you know what I'm going to do is let's call that good for the notes. I know it took 25 minutes to get here, but now let's take a look at some of the practice ones. I want to jump in straight to some word problems because we just talked about word problems and it feels like we're on that roller coaster, so let's just keep it going. Jalen spent $21.60 of the $80 he got for his birthday. What percent of his money did he spend? Well, remember, you can do this right away. We want to know what percent. So there's where the percents are. And you know what? I'm pretty sure you understand right away that this is part of his gift. This was the whole gift. So we are going to cross multiply. And we get 2,160 equals 80x. I'm going to divide both sides by 80. And here's something nice. We can actually get rid of these zeros. When you're dividing and you have zeros that kind of line up like this, that's the ones place, that's the ones place. You can cancel them. And in fact, if I had zeros in the tens places also, I would get rid of them. So it's 8 into 216, right? So 8 goes into 21 twice. That is $16. 5, 6, so this is 27%. He has spent 27% of his gift. Again, you might have looked at that and said, I can figure that out. And if you can, cool, go for it, all right? Let's slide over to number 11. Of the 180 days of school last year, Grace was absent 15. What percent of the days was she absent? Well, let's see. I'll bet 15 was only part of the day she was gone out of the school year, which was 180 days. And again, what percent means we're going to put an X for the percent part. We're now going to cross multiply, getting 1,500 equals 180x. We're going to divide both sides by 180. Then, like I said last time, we can cancel these zeros. So it's 150 divided by 18. Now remember over here where I said you could just simplify this, dividing them both by 2? I'm just going to do it just for fun. So I see that I can divide both of these by 2, and I get 75 over 9. I think I can divide them both by 3, and I get 3 over 25. And then I can't divide those any further, but I can go ahead and do this, right? So 3 goes into that 8 times with 10, right? 3 goes into 10 3 times, and here's what's about to happen. We are going to get repeating a decimal of 8.3. So this person was gone 8.3 repeating percent of the year, or the whatever. If that freaks you out, if you're like, I can't comprehend 8.3, if I were to just write it as 8 1/3, does that feel better? Because that's the same thing, right? Now, continuing on, I to be honest, in every class, I probably did one of these 4, if not 2 or 3 of these 4, because people just had questions, and that's fine. So what I would like to do now is 13 and 14. I'm going to do 14 first. 14 tricked people because of some of the terminology, like a commission. And 13, I just have a trick I want to show you. So here we go, 14. Ed's a car salesman. He makes 1.5%. So hang on. Let's go ahead. I didn't leave much room for an equal sign. 1.5 over 100. And now we just got to go, okay, which one of this, what is that part of it, or is that the whole thing? So Ed is a car salesman. He makes 1.5% commission on each car he sells. If he made $397.50 on the last car he sold, find the sales price of the car. Here's the thing. This is only part of the price of the car. That's the whole price. And if you're like, I don't understand. Like if we were to go over to Walmart and go, hey, how much money did you guys make today? And here's their giant box of money. They probably have like 50 giant boxes of money. What we could do is then say, all right, well, where do you just keep all that? And they're like, no, we give it to employees. And we give it to, I don't know, the delivery guys. And we give it to the people who grow the stuff or that manufacture the stuff. They're giving away a bunch of stuff. So that $397 is like, hey, the employees got that part. And the rest of it is going to other people. And then sure, Walmart does get to keep part of it as well, right? So anyway, so here we go. We're going to cross multiply. We get 1.5x equals 39750. Because when you're multiplying by 100, you can just go whoop, whoop, like that. And if you're like, wait, didn't you go the other direction earlier? Yeah, because I was dividing. When you multiply, you can go that way. When you divide, you go the other. So now I'm going to divide by 1.5, divide by 1.5, and I get 39750 divided by 1.5. Something you might have forgotten is when you divide by a decimal, you actually get rid of the decimal and you make it look like that. So here I'm going to redraw this, extend that out. Great. Now, how many times does 15 go into 39? Twice. That's 30. You subtract, you get 9, you drop down to 7. How many times does 15 go into 97? I believe that's 6 times, and that's 90. So when you subtract, you get 7, bring down to 5. That's going to be 5. You get 75, 0. And then shout out to Hallie, who told me, hey, listen, if you're done down here, can't you just bring these zeros up? And I was like, yeah, that's actually smarter than what I was doing, because what I did was I kept going. I was like, well, listen, let's keep track of our zeros. And then I was like, there's a 0 because of this 0. And then I said, hey, here's another 0, and let's put a 0 there. So here's what we've got. The total price of the car was $26,500. That's why 1.5% is that much, right? So now I said, let's do 13, where I said I have like a fun way of doing it. So here's what's going to happen. There are 1,560 students enrolled at Greenwood Middle School. If 85% of these students ride the bus, how many do not ride the bus? Well, let's see. Told you we could do that. We got an 85%. That's nice. I'll bet that's the entire middle school and not just part of it, right? I mean, let's be honest. That's a big number. And if it was only part of it, holy cow. So we don't know the part that they're talking about. But here's where I was like, listen, we got something a little interesting we can do. You could go ahead and do this math. You could go ahead and cross multiply and you would get an answer. But we want to know how many do not ride the bus. Well, listen, 85 do ride the bus. So if we were to find how many don't ride the bus, here's how you could do that problem. What if you just looked for the 15% who don't ride the bus? And if I just blew your mind, 85% ride the bus. Well, 100% minus 85% is 15%, right? And so now you could just cross multiply with this. But hang on, what would happen if you did this? Well, you would get your answer. Let me get rid of this real quick so I can write there. You would do this, right? And then you would subtract it from 1560. So this is everybody. I'm just going to write everybody. And you're going to subtract the bus kids. And that would equal the non-bus kids. Okay? So this is one way you could have done that, right? Over here, though, we don't have to do that. We are just looking after the non-bus kids. And then I'm going to show you one other way we could have done it. You might have said, well, listen, I either saw the 15% or I didn't. And you might be thinking, listen, I could find 10% of the school and then just multiply that by 8. Or you could have actually multiplied it by 8.5. I mean, there's at least a handful of ways you could come up with this stuff. And so if you're not seeing it, again, if LeBron doesn't see it, he calls timeout, he gets the game plan, there's the game plan. So let's go back over here and look at this. So 15 times 1560, yikes, 1560 times 15. 5 times 6 is 30, 28, 7, we need a 0, 1560, 0, 0, 4, 3, 2. So 23,400 is equal to 100x. Well, now I'm going to divide both sides by 100. Why? Because I want to get x by itself. And then when I do that, these zeros cancel. You could either cancel the zeros, or remember, you could just move the decimal twice. And the idea is that 234 kids do not ride the bus. Okay? And if you're like, well, what? I don't get it. What is this other one? Well, this other one, if we were to add, if we were to go in reverse, then what would happen is it's like 1,226, I think, are the kids who ride the bus. I'm doing some like reverse math here. 4 plus 6 is 0. Carry the 1, yep. Maybe this should have been a 3. I don't really know, or care at this point. I'm just saying you could have done it that way as well, right? So there's a handful of ways to do that. Let's zoom in and do a couple of these, just because, like I said, I helped out and did some of these. Also, you might have forgotten already, the is over of equals percent over 100. And you might be thinking, is over of. Yeah, that is weird, and I've forgotten it. Okay, 14 is. What percent of 25 is of percent 100? You cross multiply, you get 1,400 equals 25x. And again, if you're like looking at this thinking, I know how to do that, I don't need is over of, this is the last time I'll say it, maybe, then good for you. Don't do it. Now I'm going to divide by 25, divide by 25, and 1,400 divided by 25. Let's see, that is 5. That's 125, gives us 15, 56. So what percent of 25 is 14? 56%. Make sure to include your percent, okay? Because that's the question they're asking about. Let's see, what is 15% of 92? There's lots of ways you could do this. You could just do 0.15 times 92. That's one way. You could find 10% of 92, and then 5% of 92, and then you could just add them up. You could do is, what is, I don't know what is, of 92, 15%. You could cross multiply and get 100x equals 92 times 15. Let's see, that is that. 1380 divide by 100, and we would get 13.8. Let's see, is this, I might have gone way too fast, but we're about to find out. Is that 0.15 times 92? So 2 times 5 is 10. That's 3, 0. 9 times 5 is 45. There's the 4. 9 times 1, 13, 0, 8, 3, 1. No, I didn't go too fast because I have to move back twice. Move that. 13.8. Holy cow. 10% of 92 is 9.2. And half of that is 4.6. 9.2 plus 4.6 is 13.8. Oh my goodness. 3 ways to do that problem. Number 7, 16.8 is 10%. They're telling you if you took 10% of a number, it equals 16.8. Some of y'all might have seen immediately that that means the original number had to be 168. If you don't see it, that's okay. 16.8 is 10% of a number. You cross multiply, you get 1680 equals 10x. You divide by 10, you divide by 10, and you get 168. So, I know it took a whole lot less time to go through and do 1, 2, 3, 4, 7 problems than it did to kind of explain all this, but hopefully you're leaving this going, yeah, this percent proportion thing, that's pretty easy. I get it. If you don't get it, give me a shout, okay? See you later.